Hello everyone. In the series of water resource engineering, I am going to discuss CP's theory. There are three theories for the CP's analysis. First one is Bligh theory, second, landscape theory, and third, Khosla or independent variable theory. Now first, I am going to discuss Bligh theory. Bling developed a theory for the subsurface flow, and he assumed that the percolating water percolating water follows the outer line of the base of the structure, which is in contact with the subsoil. So as you can see in the figure, the percolating water from you can see in the figure from the upstream side, from the upstream seed pile. The percolating water follows the outer line or outer periphery of the base of the structure in the contact with the subsoil, and the length of the path traversed by the percolating water creep length is called creep length. You can see in the figure the total creep length will be. For example, in upstream, the depth of seed pile is D1. In the downstream, depth of seed pile is D3, and the intermediate seed pile having depth D2. So therefore, the total length traveled by the water particle is 2 times of D1 plus 2 times of D2 plus 2 times of D3 plus total horizontal width B, that is the total length of path traversed by the percolating water, that is length of creep. Length of creep. So now he also assumed that the head loss per unit length of creep is constant. Head loss per unit length of creep is constant throughout the percolating passage, and he gave the total head loss or hydraulic gradient is equal to h by l, total head loss upon length of creep. Total head loss, you can see in the figure, total head loss in the upstream, the height of water is h1, you can say assume h1, and the downstream, the height of the water is h2, so therefore total head loss is equal to h1 minus h2, and the total length of creep will be 2 times of d1 plus 2 times of d2 plus 2 times of d3 plus total width of the floor in the horizontal. So therefore the hydraulic gradient is equal to h by 2 times of d1 plus d2 plus d3 plus b is equal to constant. So the reciprocal of this hydraulic gradient, is known as Bling coefficient of creep, that is C. So therefore total length of creep is equal to L is equal to C into H. So according to Bling creep, to ensure the safety of the floor against two possible way of failure, that is piping failure and uplift failure, so the following criteria should be satisfied. For the safety against piping, the length of creep should be sufficient. The length of creep should be sufficient to provide the safe hydraulic gradient. According to the Bling creep theory, L is equal to C into H, and this hydraulic gradient should be less than equal to 1 by C for safety against piping. For safety against piping. And second, the safety against uplift pressure. Let H dash assume that H dash be the uplift pressure at any point in the apron. Apron is nothing, that is the horizontal apron. So therefore the total uplift pressure HW uplift pressure is equal to gamma W into H dash. So total uplift pressure at the base of the floor will be gamma W into H plus T, and the total unit weight of this uplift pressure will be equal to gamma W into G into 1, that is length L1 into T. So therefore for the safety against pressure, the weight of this floor should be greater than the uplift pressure, and we equate the weight of the floor is equal to uplift pressure, and we get a relation between the thickness of the floor and the head available, that is equal to T thickness should be greater than or equal to H upon G minus 1. Thickness T is equal to H upon G minus 1. And we consider a factor of safety, that is 4 by 3 or 1.33. So therefore the thickness T, the design thickness T is equal to 4 by 3 H upon G minus 1.